So today I want to take some time in deriving why the product of two negatives is positive. So maybe in algebra class you've done something like, let's say you have -1 and you multiply it by a -1, and then you would say that the result is a positive one. Or for example, you get a -5 times a -3, and then here you would say that the result is 15, positive 15. So in general, a rule that you learn in algebra class is that whenever you multiply a negative by another negative, you should always get a positive. So now today I want to show you why this is true. So in order to achieve that, we need to generalize the numbers. So for example, if we let a equal any real number, and if we let b equal any real number, then I want to show that their product is going to be just a times b. And if I'm able to show this, then I can substitute I can substitute b for any real number. And then that would make all of these statements true. Alright, so in order to begin this, I want to be on the same page. So here is just a little notation. So I want to let a, b, and c be elements of the real numbers. So any number that you can pick out of this line will follow the property, this property that I'm trying to show, with the exception of 0. Now the reason we don't include 0 is because if you have a real number and if you multiply it by 0, you're always going to get 0. So this number doesn't produce any positive or negative charge, so that's not going to help us with proving that two negatives equal a positive. So now before I begin the derivation, we have to follow these rules right here. So these are called axioms. So axioms is basically a statement that's true without proof. So you don't have to show why this is true. These are basically just observations or consequences of how numbers behave under these binary operations such as multiplication, addition, etc. So let's I'll let you review these. So let's begin. So here's how we're gonna start this statement. So I'm gonna let a, b, and c be elements of the real numbers except for 0. So as long as this is true, I want to show WTS, then a negative times a negative is going to be equal to a positive value. So here's how I'm going to begin. So my first step is just by presenting a statement that should be trivial. So here 0 equals 0, so any number equals itself. So that's fine. That's true. So now here's my second step. Algebraically, I'm going to rewrite the left-hand side of my equality. This 0, I'm going to rewrite it like this. I'm going to say this is the same thing as a b plus a negative b. And now this is due to the additive inverse property of real numbers. So any number, when you add its inverse, you should get 0. So again, I rewrote the left-hand side of my equality. So now here's my third step. I'm going to multiply the left-hand side by another variable called a. Now, since I have equality, so here let me just distinguish the left-hand side from the right-hand side. So here's my left-hand side, here's my right-hand side. Now since I have equality, whatever I do to the left, I must do it to the right in order to retain this equal sign in the middle. So then here, I'm going to multiply the right-hand side by a as well. So now on the left-hand side, I'm left with a multiplied by b plus negative b. And on the right-hand side, 0 times any real number is going to give you 0. And that's due to the 0 product property. So now on the left hand side, I'm going to do something else. Now I'm going to multiply times -1. And again, whatever I do to the left, I have to do it to the right hand side. So here, the right hand side also gets multiplied by a -1. So now I have negative, I'm just going to write it as -a, b plus -b equals 0 times -1. Again, due to the zero product property, I'm going to get 0. And then here I should actually point out that -1 times a is -a due to the multiplicative identity, that anything times 1 is itself. So now I'm going to make use of the distributive property on the left hand side. So here I have this -a, and I can distribute it to the b and to the -b. Again, that's due to the distributive property. So here I'm going to get -a multiplied by b plus -a multiplied by -b, and that's going to be equal to 0. So now I'm going to use the associative property, which basically says that I can move the parentheses around. So now I'm going to get here I'm going to get a times b plus -a times -b equal to 0. Alright, so again, all I did was just use the associative property, which basically says that I can move around these set of parentheses without changing the value of this expression. So now I'm going to do something nice here. I'm going to add AB to the left hand side. So here I have negative AB plus -a times -b, and I'm going to add AB on the left hand side. But again, whatever I do to the left, I have to do it to the right. So here I'm going to add AB. Now I'm going to use the commutative property of addition, which basically says that whenever you're adding two things, you can switch the position. So I'm going to move the AB to the position of -a times -b, and the -a times the -b is going to move to the position of AB. So here I have -ab. Here I'll keep the color so you can see what I did. So plus AB plus -a -b, and then here, due to the additive identity, anything plus 0 is going to equal itself. So here I have AB on the right hand side. So now here I have the additive inverse. Whenever we add something plus its negative, they're going to cancel out and give you 0. So here we get 0 plus -a times -b, and then we're almost done. I'm going to make use of the the additive identity, which says that anything added plus 0 is going to be itself. So here now I have -a times -b, and gives me a times b, which is exactly what I wanted to show.